Vivek, good evening. Deep, Sagar, Sushil, good evening. I'm very fine. How are you, Sushil? How is your weekend? Good evening, Aditya, Deep. Good evening, Shubham. Some students may be new today. We'll start anyway new chapter today. Don't worry about it. Ravi, good evening. Udit, good evening. Yes. Anyway, we stay at home only. Good evening, Konal. Namaste, Robert. So today we'll be starting, okay, combinational circuits. Different comments. Before going to this combinational circuits, let me explain you little leftover part, more, only one problem which is leftover part of Boolean algebra. Just now started. Okay, good evening, Upul and Madhuri. So let's see. So earlier in the Boolean algebra, we discussed if you have two functions, sorry, one function, what is the end operation or operation, etc. We have discussed. Suppose you have two functions. Good evening, Sonam. Two functions. One function is 0. R operation of 0 with 0. What is the answer? Right. Good evening, Ritik. 0. 0 plus 1. What is the answer? You know this. This is nothing great. This part you know. What is 0 plus don't care? What is 0 plus don't care? That will be equal to don't care. What is 1 plus don't care? 1 plus anything is 1. What is don't care plus don't care? Don't care plus don't care is don't care. What does it mean, sir? You have two functions, f1, f2. I want to find the OR operation of two functions. In one function, if it is 0, in other function, it is don't care. So you may treat it as 0 or 1. If it is 0, 0 plus 0 will give 0. If it is 1, 0 plus 1 will give you 1. That is the reason. So f1 plus f2 will be equal to don't care here. 1 plus anything is anything. Don't care plus don't care is don't care. Can you do the similar operation for end operation also? You take f1, f2, and f1 into f2. So if it is 0, 0, you get 0. 0 into 1, what is the answer? 0. 1 into 1. When both are 1s, then only 1. Any one of them is 0. In the end operation, it is always 0. 1 into don't care is don't care. If it is 0, 0 will come. If it is 1, 1 will come. So don't care into don't care will be equal to don't care. That's all. So using this fundamental basic, okay, we will be going to the next part. Good evening, Rahul. So listen, I have a function f1 of a, b, c and f2 of a, b, c. Two functions are there which are sum of 1 into d is d. Rushi, you have doubt? Sushil, I will answer at the last. Okay, don't worry. 1 into 1 is 1, 1 into 0 is 0. So 1 into d is d. That's all. Okay, so listen here. So function f2 of ABC. Okay, so here it is sigma. Let me take two functions. Sigma m of 1, 2. Okay, so let's take these two functions randomly taken. What is the function I want to find? What is f3 is equal to f1 plus f2? I want to find the function f4, which is product of these two functions f1 f2. What to do? How to do it? So very simple. Let's do it. You take this as A, B, and C. What is your f1? What is your f1 and what is your f2? So listen here. So f1 and f2. What is f1 taken? Sigma m of 1 to 6 and don't cares of 4. Similarly, what is f2? Sigma m of 135 and don't care of 7. Okay, I have given one homework as the last lecture. I hope I remember. Okay, we'll do that. So some of the midterms 1, 2, and what is that? 6 and don't cares of 4. Remaining is 0. Okay, similarly, what is this? 135. Sum of the midterms 1, 3, and 5 and don't care of 7. Remaining are zeros. So what is your function f1 plus f2? You tell me here. 0 plus 0, 0, 1 plus 1, 1, 1 plus anything, 1, 1, don't care plus 0, don't care plus 0 is don't care, 0 plus 1, 1, 1 plus 0, 1, don't care plus 0, don't care. So what is this function? Sum of the minterms 1, 2, 3, 5, 6 plus don't cares of 4 and 7 is your f1 plus f2. Okay, very good. Similarly, what is the function? What is the function f1 into f2? Why so many people are late today? Tell me what is f1 plus f2? It is 0 into anything is 0, 1 into 1, 1, 1 into 0. You should see these two. 0 into anything, 0, cross into 0, 0. Okay, again 0, again 0, again 0. Okay, all zeros. Okay, fine, fine, fine. So what is f1 into f2? It is a sum of the mean terms 1 only. So this is how you can find the product or sum of two functions. Okay. So not only two functions, any number of functions, you can apply the same rule. Not only OR operation and operation, you can use this for XOR operation, XNOR, or any operation, you can go by this method. So if it is fine, let me go through the question I have given as homework that will end the chapter. Okay. So this question I have given as a homework and I asked you something in the last lecture. It will affect na definitely Kunal. It depends on okay other function also. Both the functions will affect. Here don't care of 4 and 7 because this is don't care you got it here. Otherwise you don't get na. It will affect. It will affect. And minimization also it will affect. So now come to this question. Already we have done this question. You know the answer is what? Answer is 6 and 8. Okay, that we done already in the last lecture. Okay, and I ask one thing: how many combinations are possible? How many different solutions are possible for F2? Please comment how many of you have done. 2048, 1024. Remaining people 2048. Very good, very good, very good. 2 power 12, 2048 is the right answer. Very nice, nice, excellent. So let me explain to the people who have not done also. So here, first let me do this question in a different way now. So function answer is, it is a sum of the min terms 1, 6, 8, 15. Here what is that? 1, 6, 15. Here what is the answer? F1, sum of the min terms 4, 5, 6, 7, 8. Okay. Now please understand the logic. Please understand the logic for your or operation. If any one of them it is present in the output, it will present. If any one of them it is present in the output, it will present. So 1, 6, 8, 15, it is already 1, 6, 15 are there. Here what is required to get this 1, 6, 8, 15? Please comment. Very good, very good. 8 is compulsory. 8 is compulsory, should present. Okay. And also you can have 1, 6, 15 which are optional. Okay, so 1, 6, 15 are choice. I paused maybe, Subra. Okay. So up to this, clear for everybody? In this second line, okay, already here 1, 6, 15 minterms are there. Here 8 is compulsory, 1, 6, 15. I'm forgetting about options and doing, not with options. Already I done in the last lecture. 1, 6, 15 are choice, 8 must be compulsory present. That is the required condition. So if here 8 is present, here 8 is present, then you will get it in the output. 1, 6, 15 present or not, no problem, because our operation both present or one present also, you will get the same. Now come back. Here 4 is there, 5, 6, 7, 8 is there. So here 1, 6, 15 may, because end operation both are present, then only it will come. Please understand, for end operation both are present, then only it will come. For both are to be present, 1, 6, 15, you see, 1 is not there here, 6 is not, 6 is there, 15 is not there, not there. So you will strike off 1 and 15. So here 6 and 8 can present. In that 6 is a choice, 8 is compulsory. Why compulsory, sir? Please listen. If 8 is here, then only this 8 and 8 will give 8 here, and 1 plus anything. So 1 plus 6 plus 15 plus 8 will give you 1, 6, 8, 15. Here 8 is not a choice. 8 is my compulsory. What is, I am not giving number 8. I am giving a function which is having min term 8 that will give you output 1. 6 not compulsory. Manju, now please listen. If 6 is not there here, 6 will not, 6 is there here, 6 will not come, no problem. OR gate output is 6 because 6 is there here. Anything else I can say here? 4, 5 and 7, they should not present. This is important. In the function 2, 4, 5, 7 should not present. Why 4, 5, 7 should not present, sir? Listen, if 4 is here, it is here also. 4 and 4 will give you 4 because end operation. If 4 is here, it will come in the here also. But as per examiner, what is this function? 1, 6, 8, 15. 4 is not present in the output. It should not present here. It should not present here also. So what does it mean? 4, 5, 7 should not be there here. If they are here, they will come here also. Then they will come in the output. But as per examiner, they are not present in the output. So we should eliminate them. Okay, so out of the options, whichever satisfies these conditions, here 4 is there, here 4 is there, here 4 is there, wrong answer. Okay, so 6 and 8 is the answer according to options. If options not given, 8 is also, only 8 is also okay. Now my question, how many different solutions are possible. Thank you, Kunal. For F2. In this question, how many different solutions are possible for F2? Now, for that, listen here. For that, listen here. Forget in the F2, how many different solutions are possible? What is the line I have written? 8 is compulsory. Then 4, 5, 7 should not present. 6 is a choice, not 6. Okay, you see, 0 can also be choice. 1, 2, 3, 6, 9, 10, 11, 12, 13, 14, 15. Please listen carefully. These are choice. What does it mean, sir? Even you have here 0, because it is not there now here, you will not get it in the output. End operation will give you only when both are present. Here, if you have 1 also, no problem. If 1 is there also, here 8 is there, 1 is not there now. Here 1 is there. No problem for me. 1 is there here it is not there. It will not come in the output. Similarly, for 2, 3, all of them can present or may not present. It does not affect your answer for this question. Okay, so how many choices are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 midterms. 12 midterms can make how many combinations? Please comment. I have 12 midterms as my choice. I can take all of them. I can take one of them, two of them, 11 of them. How many different choices I can make? Okay, 2 power 12 choices. So 2 power 12 different solutions possible. Okay, so 2 power 2 is how much? 4 na? So 4096. How many got this answer? Very good. One person got it. I'm happy. Maybe you missed 0. Some people might miss 0. 0 is important, man. Oh, you forgot to leave 4, 5, 7. Okay. Number of choices. Listen, Ruchi, Madhuri, I don't know, you missed some classes maybe. If you have n number of midterms, you can have 2 power n choices. For example, you have 1, 2, 3. How many choices you can make? You can make 1, 2, 1, 3, 2, 3, 1, 2, 3. Okay. Only 1, only 2, only 3, nothing. Nothing means don't select anything. So how many combinations are made? 1, 2, 3, 4, 5, 6, 7, 8 combos. Similarly, if you have 12 midterms, how many combinations or different functions I can make? 2 power 12. I may take, see here, 0, 8, one function will come. 1, 8 will give one function. 0, 1, 8 will give one function. 0, 1, 2, 8, 0, 1, 3, 8. Like that, how many different functions I can make is 2 power 12. Okay, very good. So now let me start a small poll. How many of you are new to the class? This is how many of you are new to the class? Oh, today some new people, new faces, 25%. Oh, you also marked less. Anyway, even 5% also my explanation will be same, don't worry. So some people are new. I think some 20%. I excluded some people, still some 20% may be there. Okay. Fine, fine. So in our class, we are going to start new chapter now. Whatever I discussed there, fine. You can ask Abhinay, no problem. Now I am starting the new chapter, chapter 3. What is your doubt, people? Sir, the combination that we made is for f of x comma 8, but we have a bigger size of functions like I didn't made x comma 8. How will you decide x comma 8? In the place, okay, you can say x comma 8, but x can be any one of these 12 or all of these 12 also. That is 12 zeros to 12 ones of these. X is not single variable. Okay, here people. In place of that, in place of this, total I will upload today, Surah, don't worry. In the drive, I will upload it today night. So here in place of x ka jagah mein you will get all combinations. You may take all the 12, you may take any 11, any 12, any 10, any 9. Like that, 2 power 12 combinations are possible. Okay, Aditya, who is that? Google? Fine. So the next chapter we are going to, if don't care is being considered, we considering that while writing number of prime implicants. See, generally in your examiner will ask you prime implicants without don't care. But while write, if you want to write for prime implicants, generally he will consider, he will give you without don't cares only. If they give also, make all the possible groupings. That is the only logic. You must see 8 is compulsory. 8 के साथ no one is coming, 1 is coming, 2 is coming. Like that we can make the combinations. Huh? 8, 1, 2. So nothing is coming, only 1 is coming, 2 is coming, both are coming. How many combinations are possible? 2 power 2 equal to 4. Like I took 2 as a choice, 1 and 2 as a choice. I got 4 combinations. Okay. Madhuri, message me in an Academy app. I will add to. Okay, okay. Now coming to the new chapter, combinational circuits. Right. So those who are new, I suggest you to please go through the previous lectures and complete the previous lectures. Even you don't complete the previous lecture also, except 1-2 points, remaining points you will be able to understand. Okay, and feel free to ask any kind of questions. Very good, Ganesh. Aditya, I don't know where you are wrong. Please listen, Aditya. I am repeating again. Suppose 1, 2 is your choice. According to me, it is 2 power 2, 4. According to you, what is your answer? Please tell me. Please tell me, Aditya. I asked the number. According to you, what is the answer? 8 is compulsory. 1, 2 are choice. Now tell me, Aditya, how you get 8 functions? 8 is compulsory. 1, 2 are choice. How many different functions are possible? 2 power 3, how? I will make like this. Can you tell me, other than this, what are the functions possible? Aditya, please tell. Ah, 8 is not a choice, man. 8 is already present. If you make 8 without 8, 8 also choice, then 2 power 8. I understand, Sushil. That's why I'm explaining that. Okay. I'm giving you so that with his example, he can understand better. Okay. कहाँ चलना? Ashish, you can ask me after the class. Okay, because that is not in this part of the class. Na? So you should ask me at the doubt session or after the class. I can help you. Don't. In the regular part of the class, any doubt, please ask. So who asked me this? Now, Manjunath, your doubt is cleared. Is it 4 or 5? I have included 8. That is, now no midterm is selected other than 8. Okay, you come to my place, Kunal, definitely. Fine. Let's start your combinational. Someone asked me to go. We'll start it. One minute, please. 2 minutes. Just. Sushil, I don't know whether last class you have attended or not. Then please attend. Last lecture we discussed this already in the class. No, Vivek, I'm not in Delhi. I'm in Visakhapatnam right now. Right. So let's move for your most waiting part. No problem. You can just download the slides also. It will be done. Today I am not in Hyderabad. I came just 1 week back. Today I forgot to type, so I will write. So before going to the combinational circuits chapter, we should understand what is the meaning of combinational circuit, and another in your design is called sequential circuit. What is combinational circuit is the first point, present output depends on present input only. What is the combinational circuit? The first point, what is the meaning of a combinational circuit, or what kind of circuits we discuss in the combinational circuits part is your output of the circuit at any instant of time depends on input at that particular instant of time only. But there is another case called sequential, where we discuss that in the next chapter. Present output depends on present input and previous output. Okay, the next one. Here there is no feedback. In the combinational circuits, you will not be having any feedback from the output to the input. Here there is feedback. In the sequential, we will discuss the circuits where you have feedback. Next, no memory. For combinational, no memory. For sequential, memory is present. In the combinational, your examples are arithmetic and logic circuits like adders, subtractors, etc. and mux, demux, etc. Mux, demux, decoder, encoder all comes under combinational circuits. Okay, right? Yes, Bhargavi. Here, flip-flops, registers, counters, state machines, etc. This is the basic difference between combinational and sequential. In a combinational, your present output depends on present input only. In the sequential, your output depends on the present and also previous output. There is a memory or feedback here. So let's move further. Factual sense, what I want to say here is, those who are new to the class, feel free to ask me any kind of doubts in the class. If you have attended already recorded part, you might know our terminology of our system in the class. You clear your doubts of today in the class itself. Okay, so feel free to ask me any kind of doubts. Our class intention, everybody should learn. Every single person in the class should learn and go. So even a single person ask, okay, 99% of the class understand, one person not able to understand, he ask also. Let's give some time to him so that he will also able to learn. Right. So in the combinational circuits, first part we are discussing is arithmetic circuits. Everyone is an example, Bhavesh. One day you, one day someone else maybe. Right? Arithmetic circuits. Bhavesh, only you are from CSC or any other computer science students are there? Anyone from CSC? You have two more chapters only. After this, one more chapter. Kolkarna. Okay. CSC S. Okay, every time don't press S. Okay, for ECW don't press S. Computer science, please press S. I think less. S for computer science. S for computer science. E for CS. No for other. You are which branch, Aditya? Okay. Yeah, mostly E, right? Good. But some people are there. I don't know. I don't think you are the only one because in the class around 50 are there. Those who joined and all those things. ABCD options करना क्या? Okay, we'll make it after some time. Let's go to the class part. Then we'll. Okay, we'll make black background also. Don't worry. Chase after 6 chapters underneath. Don't worry. Okay, let's start the arithmetic circuits. White and black will mix it. Don't worry. So arithmetic circuits. First part I want to discuss is called half adder. Okay, half adder. So I have A, B. I want to add A and B. So please listen here. If you want to add addition A comma B, you want to do addition, not OR operation. What is addition of 0 and 0? 0. 0 and 1? 1. Actually, you should show by XOR symbol. Don't worry about it. 1 plus 0? 1. What is 1 plus 1? It is 2. 2 means 1 0. This is 2. 1 0. Here, sum equal to 0, carry equal to 1. This is how you need to write. This is the how you need to write, because if you have 5 and 4, sorry, 5 and 9, 5 plus 9 is what? 14. In that 4 is a sum, 1 is the carry which you give it to the next stage. That's why 1 is called carry. So here carry is equal to how much? 1. What is your carry here? 1. So this is the basic addition of the binary bits. It can be 0 or 1 only. So what I want to do is I want to design a circuit which will do this operation. So I have 2 bits in the input. Output, how many maximum? How many bits are possible? What happened here? No one, less comments are coming today. Comment, right? So 2 bits AB can be 0 0, 0 1, 1 0, 1 1. So here I will give the answer part contains 2. What are they? Sum and carry. Okay. So what is your sum? It is 0 here, carry also 0. Sum is 1, carry is 0. Sum is 1, carry is 0. Sum 0, carry 1. You should read like this. This is how, this is what you want to design. These are your inputs, these are your outputs. Okay, to design this, what is the sum? What is your sum? It is 1 for here and here, 0, 1 and 1, 0. What is your sum? It is 1 for 0, 1 and 1, 0. So you can say it is A bar B plus A B bar, which is A XOR B. What is your carry, sir? Carry is 1 only when both are 1s. So that is A into B. So if you take A and B, A and B, you take XOR operation, that will give you sum of 2 bits. If you take AND operation, that will give you carry of your result. This is what we call half adder circuit. Okay, so your half adder contains how many? Half adder contains 2 inputs and 2 outputs. So you can write this as like this. This is A and B. Yes, sum carry. So this is what we call half adder. Why it is called half adder? We'll come to that. Don't worry about it. First you understand the points or not. And now this is what we call quarter adder. What is quarter adder? It is a some part of your some part of, I will explain Bharti, some part of your XOR. Some part of full adder is called as quarter adder. Some part of your full adder is called as quarter adder. That is XOR gate is called as another name, quarter adder. Okay. Now, who asked Bharti? Carry how you get, sir? Please listen. 0 plus 0 is sum 0, no carry. 0 plus 1, sum 1, no carry. 1 plus 0, sum 1, no carry. If you add 1 and 1, what is 1 plus 1? Originally in the decimal, it is 2 na. 2 means how much? 1, 0. In that, this is your sum, this is your carry. So sum is 0, carry is 1. Bharti, is it clear? If you add 1 plus 1, originally it is 2. In the binary, how you write 2? 1, 0. One bit is 0 and the next bit is a carry, what we call. Expression kaisa likha? You tell me A, B, okay. From midterms. Both, all are zeros. Both are ones, then only one. Which operation? End operation, na? Here it is 0, here it is 0, here it is 0. When both are ones, then only one. It is, that's why it is end operation. Let's move further. Yes, yes. Only some part of your half adder is called as quarter adder. Now, no problem, no problem. Now listen here. Let's make one part. SUM. This is sum, na? It's not sum. It's not awesome. Okay, it's sum addition. Carry part is called carry only. Now, where we are? Half adder, right? So please listen. Let me give you one question. Implement half adder using minimum number of NAND and NOR. Which NOR? 2 input. Will you try this? Can I give it as a homework part? Answer is 5 comma 5. Okay. That I'm giving you as homework. Otherwise, yeah, I'll tell you one hint. Remember this circuit. I told this n number of times. Okay. If required, we discuss this in the doubt session. Meanwhile, you people try this. Answer anyway I have given. Na? What is this circuit? A, B. What is the answer? A, XOR B. Okay. So use this. So for some, for carry, you may be taking here and whatever you want, you can do it and try. I'm not going to. So you can try that part. I hope you can do. Next, let's move. Why it is called half adder? Let's take one example. I have a number 2345. I want to add it to 1876. What is the answer? Okay, I'm not asking you to add it, but I want the concept behind this. 5 plus 6. 5 plus 6 is 6, 11. 1 will come, 1 will go here. Now 1 plus 4 is 5. 5 plus 7, 2. 1 will go. 4. 8 plus 4 is 12. 2. 1 will go. 1 plus 2 plus 1, 4. No one is going. So here you observe except this point, which we call LSB. Remaining all cases, at a time, how many bits you are adding? 1, 2, 3. Okay, except least significant position. Okay, remaining all, we need to add how many bits? 3 bits in the addition. 3 numbers actually. Three digits. Okay, 2 of A and B and 1 from carry from previous edition. This is general edition. I am not coming to your digital part, just your basic elementary maths. Yes or no? Your first class or second class, you might have studied this part. Okay, so when you do the addition, you get the result two parts, so sum and carry. When you add the next time, you need to add this carry to your A and B. Then you get the result sum and carry. So at a time, you have the need to add how many numbers, how many bits at a time? Very good. So that can be fulfilled by full adder. That's why your previous one is called half adder. Suppose you add this. Okay. 1 minute. 1 plus 0. What is the answer? Sum 0. No, sorry, sum. Okay, fine. Sum is 1. Okay, carry is 0. 1 plus 1. 2 na, sum 0, carry 1. 1 plus 1 plus 1. How much? 3. Firstly, tell me number is 3. 3 means in the binary, this is 1, this is 1. Now you need to add all of them. 1 plus 1 plus 1 is 2. Sum 0, carry 1. So at a time, you have a need to add how many at a time? 3 at a time. This is fulfilled with the help of full adder. So full adder adds how many bits at a time? 3 bits. So let's go to full adder design. Okay. So you have 3 inputs A, B, and C. Half adder does not add the carry. Half adder is having only 2 bits. Okay, it can add only 3 bits, Sumit. You may cascade it to add more number of bits. So A, B, C. What is A and B? You can say C is nothing but C input, carry input coming from the previous edition. So here you have 8 possibilities. What are they? All zeros to all ones. Let me write it. Okay. Now you have, what is that? Sum and carry. You have sum and carry. You add all of them. Sum is 0. Sum 0. Sum 1. Now I will tell you one simple question which is asked in one interview. Okay, can you do this or not? Tell me. Design a circuit which counts of 3-bit number. Can you do this problem? Question is clear. You need to design a circuit which counts the number of ones. Okay, in the 3-bit number. What is that circuit? No, no. Very good, Deepanjali. It is full ladder only. Alcha, very good. It's full ladder only. Full ladder is indirectly counting the number of ones, man. Here 1, 1, 1. How many ones are there? 3. That's why it is 1, 1. Okay. Here Madhuri, please understand. This carry is coming from previous edition. This carry is not coming because of addition of these two. This is coming because of this edition you are getting carry. Because of this edition you are getting carry. Not because of these two. Okay, so please understand, it is very simple. Full ladder is doing that job. Full ladder will do what is that? Which counts the number of ones in the input. Yes or no? Here, how many ones are there? 2. That's why your answer is 1, 0. I am not saying only some. I am not saying only some, man. Okay. If it is only odd number of ones, all those things we know it already. I am saying together. Together, this full ladder answer. What is the value of 1, 0? What is the value of 1, 0? 2. That will tell you number of ones is 2. What is the value of 1, 1? 3. That will tell you number of ones are 3. So you understand the concept? Who will do that job? Your full ladder is doing the job. Very good. For 5, what is the problem, man? Who is that? GP. 101. How many ones are there in 101? How many ones are there, GP? 2. So 10 means 2 only, na? Yes, Amitabh ji, you see the arrow direction. Yes, Sushil, I don't erase everything, but this part I have erased because I need to write something. Yes, answer is in front of you. We need to just make it. So I can say I'll write it here, Sushil. Don't worry. Full ladder gives number of ones in 3-bit number. Very good. Now, what is S? What is sum? What is sum? It is sum is the sum of the min terms 1, 2, 4, 7. It is nothing but min terms 1, 2, 4, 7. You know this very well. A XOR B XOR C. This part we know it already. Earlier, n number of times we have done this. What is carry, sir? What is carry? Sum of the min terms 3, 5, 6, 7. It is MSB, it is LSB, Rahul. It is MSB, it is LSB. If you read like this, 1, 1. If you read this is 0, 1, na? If you read like this, it is 1, 0. In this way, if you read, it will tell you how many number of ones. Okay, some of the min terms, 3, very good, Asif. 3, 5, 6, 7. So you remember this, very good. So let me do it, no problem. 3 is A bar B C. 5 means 101 na A B bar C. 6 is A B C bar. 7 is A B C. So if you take first two में A bar B plus A B bar common, it is XOR. Second, you take A B common, C bar plus C will give 1. That is A XOR B into C plus A. Okay, this is one method. Otherwise, take K-map. Yes, majority gate. Very good. We are very okay now. Much practiced with your K-map. Some of the min terms 3, 5, 6, 7 in this problem done a number of times. It's a pair. It's a pair, and it is a pair. So what is the answer? Your carry is equal to AB plus BC plus AC. Like that also you can say. Very good. So now let me draw this. So you have three variables A, B, C. Okay. So the first one is, what is your sum? It will come. We have already done in the class also, Aditya. We have added 3 times. All those things are done already. A XOR B. In any method, you get the same answer. XOR C. So what is your carry? AB plus BC plus CA. So this is your sum. This is your carry. There is another way to draw the carry. What is that? A XOR B into C plus AB. This will also give your carry. What is this method? You can use generally practically we make it by taking two input. That's why we show like that. So A XOR B into C plus AB. One answer. Otherwise, it is AB plus BC plus AC. Anything is correct. What is sum? A XOR B XOR C. Okay. Right. Now I will ask you one answer. Please tell me, first method is better or second method is better? For carry. First method. It depends. Please listen. It depends on your requirement. Now please see. If you take here the gate delay as a TPD, this gate delay as another TPD, total delay is equal to 2 times TPD. Two gate delays are required to get the output. Here also two gate delays are required. But here, what is your total delay? It is already TPD plus TPD plus TPD. How much? 3 gate delays. But here only 3 gates, but here 4 gates. But here how many? 4 gates. So you should compromise on one thing to get the other thing here. Already XR will be there now. Please understand that it is not extra gate for us. It is already used for some. For some you have that we are using. We are asking, please give one output here. I will use it like this. Okay. So what we can say here is my advantage here in this case advantage is less gates. Here advantage is faster. It depends. It depends on the design. Sometimes both may be possible in some cases. But here what is that? You should compromise on one to get the. Is it clear, everybody? Yes, Aditya, that's what I'm saying. Very good. New students also please comment. New students also please actively involve in the class. Every single comment you should make, whether it is simple or not, doesn't matter. Okay, so let's move further. Implement full adder using half adders. We need to make full adder using half adder. It is a very simple regular question. Take two half adders. If you give here A and B, you will get here sum and carry. What is sum? A XOR B. What is carry? AB. Okay. Now again, for its inputs, you give here this one and C. What will you get as a sum and carry? I am giving its name as AB. Okay, please don't understand. Don't take it wrong. Now tell me, what is the sum is XOR operation of its two inputs. What are its two inputs? These two. So A XOR B XOR with C. What is this one? It is AND operation of these two. What is AND operation of these two? A XOR B into C. Now take this and this connect to OR gate. What will you get? AB plus A XOR B. Please, today's class we discuss less number of problems because I need to give you the concept. Tomorrow we do more number of problems. So that will give you your carry, that will give you your sum. So one full adder will give you two required two half adders plus one OR gate. What is the required condition to make a full adder? हमको क्या चाहिए? What we need? Full adder requires two half adders and one OR gate to make the full adder. That is the required condition. I don't think anyone having doubt in this. Carry is always equal to multiplication of its two inputs. Sum is XOR operation. Carry is product. What happened? This C is a Cn only. I am not connecting this C here. This is a Cn. Please understand. Earlier also I told here. This we are adding these three. A is one input, B is one input, C is one input. We are not adding a carry of these two here. Okay. This C can, please understand this like this. When AB are 0 zeros, please listen. You are designing one circuit like this. When AB 0 0, when A, please listen first. AB 0 0, carry coming from outside can be 0 or 1. Similarly here, AB 0 1, carry coming from outside can be 0 or 1. What is the corresponding outputs? When AB is 1 0, carry coming from out can be 0 or 1. What will be the output? When AB is 1 1, carry input can be 0 or 1. What is the output? That is the meaning of these combinations. Don't take this 1 plus 1 is a sum 0, carry 1. I will take this again and add it. Please don't take like that. You understand? These two are my bits. Carry coming from the previous edition. So previous edition may give carry as 0 or 1. Depends on the previous edition. I will decide. Okay, so carry is coming externally. Please understand that. So I'll write here from previous edition. Yes, right us. So from the previous edition, whatever that you get, this is your CN. Okay. In this case, A, B, and third input is this one. This is the carry coming from previous edition. Next, let's move. Implement full adder using minimum number of 2 input NAND and NOR. I will do this. Very good, very good. What is this circuit? I told you, you should remember this in your mind already. What is this circuit? It is XOR operation. A XOR B. Now what I will do is I will add one more XOR gate here. That is, it is replication of the same figure again. Now here I will give C, then what I get is XOR of A, XOR B, XOR C. That will give you a sum. So for getting carry, your job is to get carry. That is service. If you are able to get carry, your job is done. To get the carry, what is the required condition? Just check it. AB plus A XOR C is the required condition. So please listen. What is this output? A XOR B into bar. Now let me take this AB. What is that NAND gate here? Very good. Okay. Now, why? What is the reason? Very good, very good. Not okay. A XOR, sorry. Sum and carry are self-dual functions. Why this is happening? Sum and carry. What is sum? AB plus BC plus AC. What is carry? A XOR B XOR C. You can check it at home, or I gave you the best technique to check it. Because they are self-dual functions, NAND and NOR implementations are same. You know, if NAND gate is replaced by NOR gate, XOR will become XNOR. And similarly, this will become its dual. NAND and NOR are Originally dual to each other. Okay. Okay, no problem. NAND and NOR are dual to each other. If you replace NAND gate with NOR gate, the function will become its dual. But because they are self-dual functions, dual and the original function are same. What is sum? A XOR B XOR C. What is carry? You take any method, whether it is minimized or non-minimized, it is always self-dual. Okay, we know this already. These are self-dual. Because of that, NAND implementation and NOR implementation are same. Is it okay? This part we discussed already. Shall I proceed further? Right. What's happening? New gates are getting invented. So let's take a small question. Using half adders. Definitely write this one. AB bar plus BB XOR C. Like that, I want to say is we can connect AB factor is in, because most of the people think that they know it. I will explain it after that. You say whether you know it earlier or not. Before that, first half subtractor is easy to understand. Full subtractor is where I want to concentrate more, so that I want to give you the proper picture. Good. So let's take some basic subtraction into mind. How to do this subtraction? 5 say 6 cannot be subtracted. I didn't ask you the answer here. Why you are typing 9? Do you feel it is difficult to get 35 minus 26? My point, you should say the point. How to do this means 5, 6 cannot be taken from 5. So what to do? You should take a borrow. Borrow means here, say here 1 will come. That 1 will become how much? That 1 will become how much? Yes, 10. Now 15 minus 6 is your answer, 9. In the 3, 1 is given, left is 2, 2 minus 2 is 0. Okay. Borrow means other. I don't know the word. Right. Now listen here. This is 10. Why it becomes 10 here? It is decimal. In the decimal, every unit is having a positional value multiplied with 10, 1, 10, 100 like that. So when it comes to lower position, it is 1 is equal to 10. From here to here, it becomes 1 equal to 10. From here to here comes another 10 like that. Okay. So please listen. Here 3 is 30. Here 5 is number 5. From here to here 1 now comes means it is equal to 10. This basic you should have in your mind when you do the binary subtraction also. 1 minus 1 happily you can do. 0. 0 minus 0 is also not a difficult thing for me. 1 minus 0 also 1, not a difficult thing. Now 0 minus 1, I should subtract 1 from 0. So what I will do is I will take borrow from my higher order friend. From higher order number, we take a borrow. That borrow will become decimal way, it becomes 2 now. In the binary, it will become how much? Sorry, decimal it becomes 10. In the binary, it will become 2. 2 is equal to how much? 1 0 in the binary. Okay, this what you are bringing is called as borrow. You are taking borrow from the higher order. You are taking 1, but it is becoming 1 0. That is actually 2 here in the binary. So 2 minus 1, what is the answer? So this is what we call difference. Yes, 1 0 in the respective base, correct. This is what we call borrow. What you are bringing from higher order, na, that is borrow. What you are not, what you are getting after subtraction is called difference. So similar to carry and sum, here your result contains two parts, borrow and difference. So shall I proceed? This basic subtraction, everybody clear? Right, very good. Okay, now this is A, B. Now you have difference, B, and borrow, B naught. What is the meaning of D? It is difference. What is the meaning of B naught here? Borrow, taken. कहाँ से ले लिया? From where he got this borrow? From a higher order. Okay. So 0 minus 0, difference 0. I need not take any borrow from any person. 0 minus 1, I am not able to manage 0 minus 1. So compulsory I should take what? Borrow first. Then it will become 2. 2 minus 1 is 1. 1 minus 0, 1. No borrow is required. 1 minus 1, no borrow is required. Is it clear, this table? X or B, that is your sum taken S1, not taken 0. Okay, you are taking 1 from higher order. Similarly, what is your borrow expression? It is 1 only here. Only here means what? Very good, very good. A bar into B. 0 1, na? It is A bar B, not AB bar. It is 0 1. That is A bar B. So if you want to make AB listen, this is XOR operation. It will give you difference. If you take here one inverter and borrow, sorry, AND operation, that will give you borrow. You observe half adder and this circuit, what is the extra part required? Only one inverter is the difference between half adder and half subtractor, HA and HS. So someone asked me to repeat the table, no problem, I can repeat the table. Listen. So 0 minus 0 is 0. You don't need to borrow anything for subtracting 0 minus 0. Similarly, forget about the second line, I will come back. 1 minus 0, 1. You don't need to take any borrow from anyone. 1 minus 1. Okay, you don't need to get any borrow. You will be left over with 0. Or simply, you have 1, your friend asked 1. So you have 1, your friend asked me, you 1. So you can give 1 to your friend, you left over with 0. You have 1, your friend asked nothing, still you have 1. Here you have 0, your friend asked 0 only, so you left with 0. But here what is the rule? You have, sorry, here you have nothing, but your friend asked to borrow. You need to take, you need to give 1 to your friend. Okay, So for that, what to do? You cannot give 1 directly. So first you take the borrow from your higher order. Then you will get 2. 2 minus 1 is 1. No, borrow is coming from higher order. We assume, okay? We assume borrow coming from higher order. Okay. Samir, why are you worrying? Borrow comes means what is the sign? Simple rule. Samir, borrow comes means it is a negative. Result is negative indirectly. Okay. No borrow comes means result is positive. In actual sense, we see for it is only single bit. When you have multiple bits, we see how to do it with 2's complement everything. Okay, here what is that? If you need to require, what does this table means? You require to take 1 borrow to do this operation. You require to take 1 borrow to do this operation. Okay, very good. So now I will give you one small homework that you can do. Implement HS using minimum number of 2 input NAND and NOR. What is the answer? 5, 5. This part you try as a homework. Okay. Now comes to the important part, that is full subtract. Okay. Half subtractor. Now we'll be discussing full subtractor. You have 2 functions. You can do double complement for XOR. There is a standard format. I told you how to do it. Okay, for finding number of NANDs and NORs, I have given the method. You should follow the same method. If it is an AND OR function, you should say NAND NAND. If it is a dot operation, go by number of bars. So let's come here, full subtractor. Why full subtractor is required? I am not visible. What happened? Remaining people, I am visible to you or not? I am visible. Maybe refresh, please. Anupama, please refresh. Okay, listen. Full subtractor. Okay, here your concept is important. So, for example, of you know here, tell me what is BA? Borrow in and borrow out. What is the meaning of borrow out, man? Carry means it will generate. So carry out, there is a meaning. Borrow from previous. After borrow, same borrow. Right. I didn't see any relevant answers or good answers. So as I told earlier, borrow from previous input. Borrow after subtraction. You're missing something. Missing something. Borrow from previous subtraction means what is that? Borrow required to do that subtraction. Listen. Let's come. Let's 1 4 take. Okay. Please listen first. Please listen. Understand the concept properly. Okay. So you cannot take 8 from 3. You know this. Because of this, what you do? You come here. You ask him, please give some borrow. You will give. This fellow will give 1. Okay. This fellow will give 1. 1 minute. Once he has given, he is left over with how much? 1 minute. Let me change the question a little better. He has given here, then 10 comes, 10 plus 3, 13 minus 8 is 5. Okay, so 1 is given, he left over with 4. 4 minus 5 cannot be done. You should take here. Okay, you should take from here 1 borrow. You should take from here, otherwise 1 minute. 1 minute. Let me take 2 examples I will give you. So here he has taken 1, 13 minus 8 is 5. So what is the leftover for him? Leftover is 4 now. So 4 minus 4 is 0. Okay. Now 5 minus 4 how much? 1. 2 minus 1, 0. Now you observe here, first here it is 5 and 4. Here also it is 5 and 4. But my results are different. My results are different. Okay. 2 minus 1 is 1, right? So after studying this much, we forget what is 2 minus 1. Right. Okay. So please listen. 5 and 4. Here also 5 and 4, but results are not same. Results are different because here you should consider not only 2 bits, 2 digits. One more digit is to be considered. What is that one more digit? Ah, very good, very very good. This is what we call borrow given because already okay or borrow given to the lower because you are very much concerned. You have given some borrow to the lower order. Okay. Now this is you may require some borrow here, na? That is borrow to be taken from higher order. Is this point clear? For this 5, we are speaking with respect to this 5. With respect to this fellow, he is your friend. Okay, for this friend, this one is he has given already to the lower order because lower order is in a need. Okay, so he has given, that is what we call borrow given. After giving, he left with something na. So to perform his subtraction, how much he requires, that is called as borrow to be taken. Borrow to be taken from higher order. Now let me take one more example. One more example. You told the same, very good, Ganesh. 2 5 2 5 5 3 minus 1 5 5 8. I'm taking the example such that it will give you better understanding. Okay, now you have taken a borrow of 1. So 3 minus 5. So what is the 13 minus 8 is 5. Now after giving this, he is left with how much? After giving this one, he left over with how much? 4 only. So now 4 minus 5 not possible. He will take from higher order 1 borrow. Then it will become 14. 14 minus 5 is 9. Now he is left over with 4 and he will take a borrow. Then it will become, listen, it will become this 1 will come here. 14 minus 5. 9. 1 is given, 1 minus 1, 0. So you understand here, at any point you understand two things. Borrow already given, borrow to be taken. Okay. So based on that, you will get the result. Is it okay? This basic maths. So let's move further to your binary also. Okay, now you tell me. 1 minus 1. What is the answer? 0. 0. 0 minus 1. Please listen. He will take a borrow of 1. It will become 2. 2 minus 1. 2 minus 1 is 1. Because he has given 1, he left with how much? He left with how much? Because he has given 1, he left with 0. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. So here you understand he has not taken anything from here. Okay, like that we do the subtraction. Now you understand this. What is the meaning of BI? Borrow given to lower order. What is this BI? Borrow already given to your friend. What is B naught? Borrow to be taken. Amko, how much you need, okay, to complete this process? Borrow to be taken from higher order. Okay, so let's start the game. Now listen here. A and B are your weights. So firstly tell me, if C is 0, if C is 0, you know the answer very well. If C is 0, what does it mean? It is nothing but we have not given any borrow. It is same as half subtractor. Yes or no? You have not given anything, man. You have not given anything here. So now you have not given any borrow to the lower order. 0 is the borrow given to the lower order. Now 0 minus 0, what is the answer? Comment please. Start commenting. You don't need any borrow to do this operation. Stop, stop. Again, 0 minus 1. Listen, listen, listen. To perform 0 minus 1, I need to take borrow or not? To perform 0 minus 1, I need to take borrow. So first I will take borrow. I will get to 2. 2 minus 1 is 1. Is this line clear? This is nothing but your half subtractor only. So here also no borrow is required. It is 1. No borrow is required. It is 0. This is nothing but half subtractor part only. Nothing new here. Nothing new here. Nothing special here. Now you understand. If I take borrow, if I have given borrow, please listen. Now concentrate. Only this part. You have already given borrow. You have how much, man? You have how much? Nothing you have, but you have already given something, 1 to your friend. You don't have anything, but you need to give 1 to your friend. First, what do you need to do? आपके पास कुछ नहीं, but आपका friend के लिए एक देना चाहिए. You don't have anything, but you need to give 1 to your friend. You want to give, okay? Already given. दिया तो you should first take borrow. Take borrow, you will get 2. 2 में 1 friend को दिया. What is the leftover? 1. I will repeat this again. Please listen. I don't have anything. I need to give 1 to my friend. So for that, first take borrow. Borrow is taken. Then I will get 2. 2 minus. So in that 2, 1 is already given now. So what is the left? 1. 1 minus 0 is 1 is the answer. Is this line clear to everybody? Okay, come. Listen, listen. Again, same story. What is your problem, Kuldeep? Please ask me. You have you have 0 in your pocket. You have 0 rupees. Okay, but your friend want 1 rupee. Your friend want 1 rupee. What to do first? What to do first? First you take a borrow. Yes, you get 2 rupees. In that 2 rupees, 1 rupee friend ko diya. You left with 1. 1 minus 0 is 1. Kuldeep, clear? First you have given to C, then you subtract A minus B. This is the rule. First give to C. Okay, first take borrow and give to C. Hamara friend, hamara guest. Okay, right. Now come here. So again come here. Tell me. First tell me. I have 0 only, but my friend want 1 rupee. So first I need to take a borrow. Borrow taken, I will get 2 rupees. In that 2, 1 is already given to friend. 1 is left. 1 minus 1, how much? Is this line clear? I don't have anything. My pocket is empty. My friend require 1 rupee. So first I will borrow, then I will get 2 rupees. In that 2, 1 is given to friend already. Remaining 1 is left. 1 minus 1 is 0 is in my pocket again. Okay. So ये मेरा expenses है. ये मेरा friend का expenses. Now come here. Come here. You have 1 only. Your friend asked 1. So give him. You left with nothing. 0 only. 0 minus 0 is 0. No borrow is required. Now again, you have 1 rupee. But your friend came and asked 1 rupee. Give him first. You left with how much? 0. Now 0 minus 1 ke liye, we should take a borrow. Then it will become 2. 2 minus 1 is 1. That will fill your entire table. In any particular row, third row, fourth row, fifth row, any row you have any doubt, please ask again. What happened? No comments. Once last one, Swapnil, listen. You have, please listen, Swapnil, you should study like this. You have 1 rupee. You have 1 rupee. Okay. Your friend requires 1 rupee. First give him. First priority friend. Friend ko diya, 1 rupee given. Okay. Now you have nothing, 0. Okay. Once you have given to friend, you have 0. But you need to give one more one. Okay. So for that, what you need to do? Take borrow. Then it will become take borrow. Then you will get 2 rupees. 2 minus 1 is 1. Here you are subtracting. You should take third row and ask to friend. Want to do this? One is to and this sum 0, no borrow 1 1. See here 1 minus 0 is 0. 1 minus 1 is 0. Now 0 minus 1. 0 minus 1 is how much? 0 minus 1 means 1 borrow and 1. This is blind way. This understand not changes. It will not satisfy associative property. Okay. Satisfy associative. Okay. This is one of C. Then it will do A minus B. Yeah. What is your difference? What about the bond? So some of them are that's it. Figure out same figure. Very good. So H or B in whatever. And how you can pen around full subtractor using half subtractor minimum here. Thank you. What is there? Why good and another so listen. The people will feel some visitor. Let me quickly revise in 1 minute. This is what we have discussed. You have an object to use this. You also use for you keep A 0, sorry, B equal to 1, you will get A bar. Complement is possible. Similarly, if you keep B equal to B bar, then B bar whole bar will give B. X not B. Yes, you can do. Possible. You can convert this into but half adder and you can do it. No problem. I have the link, I will provide. August 7th, Meghna, because every Sunday we are having off and we are taking only 2 hours, not 3 hours now, so it will take little more time. So last slide, no clarity. What is that? Good night, Port Stadium. Okay. which a static one will occur in end or all those things we discussed, right? Oh, I am calling you Rahul instead of Rohit. Another student is there, I think, with name Rahul. Maybe, yeah. Above you, some comment is there. Good night. Rahul and Rohit, the two students are there. Little confusing. Fine, everybody. Good night. We'll meet tomorrow, same time. Tomorrow we'll see more number of questions. So that is a carry header and all those things may come. Okay, parallel header, etc. Yeah, this is nothing but borrow given already. This input is telling you what is the borrow given already. Name is the Caesar. Thank you. Good night.